Hi friends, welcome to Chemiphilic channel. PG TRB chemistry major prepare பண்ற நண்பர்களுக்கான பதிவு யூனிட் 8 ஓட continuation. Aromatic electrophilic substitution. Carbon atom which is attacked changes its state of hybridization from sp2 to sp3. Hybridization அட்டாக் ஆனதுக்கு அப்புறமா sp2லேருந்து sp3க்கு வந்து சேஞ்ச் ஆகிடும். திஸ் டைப் ஆஃப் கார்போனியம் அயான், இந்த வகையான கார்போனியம் அயானை வந்து சிக்மோ காம்ப்ளெக்ஸ் அப்படின்னு சொல்லி சொல்கிறோம். ஸோ த எலக்ட்ரோஃபைல் இஸ் ஜாயின்ட் டு த பென்சீன் ரிங். எலக்ட்ரோஃபைல் பென்சீன் ரிங்கோட ஜாயிண்ட் ஆகி நியூ காம்ப்ளெக்ஸ் நியூ பாண்டை வந்து ஃபார்ம் பண்ணும், விச் இஸ் சிக்மா பாண்டு. த அதர் நேம் ஆஃப் கார்போனியம் அயான் ஆர் பென்சீனியம் கேட்டையான், சைக்ளோஹெக்ஸா டையினைல் கேட்டையான், வீலன் இன்டர்மீடியேட். ஸோ இப்படி ஃபார்ம் ஆகிற கார்போனியம் அயான் வந்து அன்ஸ்டேபிளாக இருக்கும். கம்பேரிசன் ஆஃப் அடிஷன் காம்ப்ளெக்ஸஸ் ஃபார்ம்டு பை ஒலிஃபின்ஸ் அண்ட் அரீன்ஸ். ஒலிஃபின்ஸோட எலக்ட்ரோஃபைல் அட்டாக் ஆகிறப்போ ஃபார்ம் ஆகிற அடக்டுக்கு பேர் பை காம்ப்ளெக்ஸ். when an electrophile attacks an olefin, it forms an adduct known as pi complex. In the case of aromatic electrophilic substitution, electrophile attack the benzene ring and initially forms this type of pi complex before actually removing an electron pair from the ring to form sigma complex. Aromatic electrophilic substitution reaction la electrophile attack benzene ring la initial pi complexes form பண்ணும் before actually removing an electron pair. அதாவது எலக்ட்ரான் பேரை வந்து ரிமூவ் பண்ணி சிக்மா காம்ப்ளெக்ஸஸை ஃபார்ம் பண்ணுறதுக்கு முன்னாடியே வந்து பை காம்ப்ளெக்ஸை வந்து ஃபார்ம் பண்ணும். இந்த கேஸ் ஆஃப் ஒலிஃபின்ஸ், த ரியாக்ஷன் இஸ் கம்ப்ளீட்டட் பை த அடிஷன் ஆஃப் நியூக்ளியோஃபைல். நியூக்ளியோஃபைல் ஆட் ஆகிறதோட அந்த ரியாக்ஷன் வந்து கம்ப்ளீட் ஆகும். பட் இன் அரீன்ஸ், த எக்ஸ்பல்ஷன் ஆஃப் அ ப்ரோட்டான் புரோட்டான் வெளியேற்றப்படும். அடிஷன் ஆஃப் 1 mole ஆஃப் ஹைட்ரஜன் டு பென்சீன் இஸ் எண்டோதெர்மிக். Reduction of ethylene is exothermic. Aromatic compounds react less rapidly than olefin with a given electrophile. Benzene is hardly affected by bromine, whereas ethylene readily reacts with it. Dimethyl and acetanilide undergo bromination more readily than benzene. Reason: substituents can stabilize the carbonium ion intermediate. First step of aromatic electrophilic substitution, the benzene and the electrophile come to form a new bond between them. So because of this bimolecular attack, electrophilic aromatic substitution is often known as SE2 reaction. Presence of Lewis acid such as AlCl3 will increase the rate of formation of sigma complex and will facilitate electrophilic aromatic substitution. Orientation and directive influence: groups which increase the electron density on the benzene ring either by inductive, mesomeric or hyperconjugative effect are said to activate the benzene ring. Rate of reaction increases than that of unsubstituted benzene. These groups direct the incoming group to ortho and para positions. If the group is electron withdrawing, it will deactivate the benzene ring and will direct the incoming group to meta position. The directive influence decides only the predominant and not the exclusive course of the reaction. As a result of kinetically controlled reaction but not thermodynamically controlled reaction. For reversible reaction, thermodynamically controlled reaction. Factors affecting stability of the intermediate: inductive effect, resonance effect, mesomeric effect of the substituent. These are the factors affecting stability of the intermediate. Electron donating groups: O minus Nr2 NHR NH2 OH OR NHCOR OCOR and halogens activate benzene ring. Because of the minus I effect of halogen, they make the ortho and para intermediates more stable than less reactive meta but less stable than unsubstituted benzene. Intermediate stability. For halo substituted benzene, benzene is greater than that of ortho, para is greater than that of meta. Electron withdrawing groups NR3, NO2, CN, SO3H, CHO, COOH, COOR, CCl3, NH3 plus. Deactivate the benzene ring due to inductive effect. Neither electron donating nor electron withdrawing. Alkyl groups, aryl groups, COO minus group. All are activator except some aryl group having minus I effect act as deactivator. All orthopara directors, the atom directly attached to the ring has at least a pair of unshared electrons, exception aryl group C6H5 and alkyl group. Orthopara ratio is 2:1. Apart from this, a little meta product is always obtained in all the orthopara substitution reactions. The yield of para product is more than that of orthoisomer because of the steric hindrance to the incoming group, but the group already present. Orientation in benzene ring containing more than one substituent. This depends on both the electronic and the steric effects of the group already present. Substitution takes place at position 4 because it is ortho to 3 and para to the position 1. Substitution does not take place at position 2 because of the steric factor. At position 5 also no substitution takes place since it is meta position to the methyl group. CH3 is orthopara directing. If a strongly activating group competes with a weak one or with a deactivating group, the strong group controls the reaction. Orthocresol. This product is more, this is less favor. Here OH group is strong orthopara directing group, methyl group is weak orthopara directing group. Meta directing group is meta to an orthopara directing group. The incoming group goes to the ortho position to the meta directing group rather than ortho position. So this is main product and this is very small. The incoming group enters the position ortho to the meta directing group is called ortho effect. Effect of reaction conditions on the position of the incoming group. The reaction conditions modify the directing effect completely. Example, aniline in presence of strong acid gives no orthopara product. The lone pair of electrons utilized by H plus to give anilinium ion which is meta directing. Sulfonation of naphthalene gives the alpha sulfonated product at 80 degrees Celsius but at higher temperature beta isomer is obtained. Phenol and toluene is more susceptible to electrophilic attack than benzene, but chlorobenzene is less susceptible than benzene. For hydroxyl, plus R is predominant than minus I effect. For methyl group, plus I and plus R effects. For Cl group, minus I effect predominant than plus R effect. Aryl ketones, the RCO group has minus I and minus R, hence less acceptable than benzene. Nitrobenzene is very less reactive than benzene towards electrophilic aromatic substitution. Decreasing order of orthopara directing strength. Nitration. Nitrating mixture is con HNO3 plus con H2SO4 N2O5 NCCl4 in presence of P2O5 removes water in the reaction. NaNO2 N2O4 gives good yield. Nitration in alkaline medium can be done with esters of nitric acid such as ethyl nitrate. Other nitrating agent NaNO2 N2O4. Nitrosation. Ring nitrosation with HNO2 is normally carried out with active substrate such as amine and phenols. Primary aromatic amine gives diazonium ion when treated with HNO2, but secondary amine gives N-nitroso compound rather than C-nitroso compounds. Instead of HNO2, we can use NaNO2 plus HCl and HBr. NO plus is less reactive than NO2 plus. Diazonium coupling. Substitution is mostly para to the activating group unless the position is already occupied. For amines, the solution mildly acidic or neutral. For phenols, the solution must be slightly alkaline. Sulfonation, electrophile is SO3H, which is neutral, not positive, negative charge. Reagents, concentrated H2SO4 or fuming H2SO4. Sulfonation done with ClSO3H. If using oleum H2S2O7, rapid reaction takes place. Sulfonation is reversible. Sulfonation must be carried out in the absence of water. Sulfonation has small negative enthalpy. Halosulfonation. Similarly, instead of H, substitute Cl. இதோட கண்டினியூஷனை நெக்ஸ்ட் வீடியோவில் பார்க்கலாம். தேங்க்யூ.